Welcome to Internal Laser Diaphragm Alignment from Acquip Incorporated. Hi, I'm Damian Josephsberg. Thank you for joining me for this presentation. During this presentation, you will learn about the internal laser diaphragm alignment process for a steam turbine. At the end of this presentation, you will be given some information on how you can have Acquip come to your facility and perform an internal laser diaphragm alignment on your steam turbine. Using a laser for internal diaphragm alignment has applications in both large and small steam turbines. The technology and process works for all fuel types as well. There are numerous benefits of using a laser to do a diaphragm alignment. The first is the speed of setup. It generally only takes 45 minutes to an hour and a half to set up a laser for a diaphragm alignment on any size turbine. Other work can be performed at the same time that the laser alignment is going on. Because there is no wire or mandrel in the way to be disturbed by the beam of the laser, it can be broken without affecting any of the readings. Using a laser provides a simple, repeatable check for the diaphragm alignment. At any point in time, other positions can be remeasured in order to see that the measurements repeat. It is also non-user dependent readings, because it is relying on a computer and sensor in order to gather information. From the laser to the measurement point deviation, the user has very little to do with the accuracy of the readings. Points can easily be remeasured after long periods of time. This is possible because all of the information from all the other measurements will remain stored in the computer. If the laser needs to be broken down and set back up, this is a quick and easy process. The laser system also will account for thermal changes if need be. The measurements are all based off of two known set points. So in order to take measurements again on a point that was moved, all you have to do is take three positions: the two set points and the position that was moved. All the presets are programmed into the computer. This accounts for the catenary curve, the thermal growth that may occur, and the tops on to tops off calculations. This helps avoid math errors when finding out what your final alignment results need to be. The data can be instantly viewed from different perspectives. This helps us because we can see the easiest line to align the rest of the measurement points to. The procedure for laser diaphragm alignment is a fairly easy and simple process. First, we need to enter the dimensions of the turbine into the computer. These are each of the measurement points. Then we set up the laser. After we do that, we can measure each position as it references to the laser. Then we view the results. We make any corrections that need to be made, and then as always, we should confirm all moves for our final set of results. The first thing we need to do is enter the dimensions of the turbine. This is like building a template of all the possible measurement points that are going to be in the diaphragm alignment of this turbine. We need to enter the total distance of the turbine section that we are measuring. Anything that may possibly be included should be in this total distance, all the way from the laser going all the way out to where our last measurement point will be. We need to measure each one of our points from a common reference. This is so if any of our points have any axial movement, or we need to enter another measurement point later, this will be an easy test to be accomplished, and it won't affect the dimensions of any of our other measurement points. All of these measurement points should include the diaphragms, the bearing housing, the oil deflectors. This will ensure that we have a complete group of measurement points when we go on to take our measurements later. Once all the dimensions for the turbine have been entered, we then want to set up the laser. The laser needs to be placed external to all the positions being measured. We want to have it in a very stable area. This is generally at the turbine end of the turbine. So we set the laser up at the turbine end of the turbine and shoot it towards the generator end. Once we have done this, we want to make sure that this laser is referenced to the general center of the bore line. Now what this means is it doesn't have to be in the exact center of the bores that we are going to measure, but it has to be within 1/8 of an inch of the center. In order to set the laser up so that we were in this general centered position, we need to set up the laser from the nearest bore to the furthest bore away in the center. This way, all the other points in between will have the laser going through the general center of it. Once your laser is set up, 85% of your work is done. Once our laser is in place, we can start taking measurements. In order to start taking measurements, we have to make sure that there is no movable position that we are going to be taking measurements on. If any diaphragms are loose or any packing is loose, we want to make sure that this is all locked into place, either by putting some cardboard or some garlock around it, or by moving all the diaphragms over to one side of the turbine and tightening them down. After that is done, we can start taking measurements on each of the individual bores. We should do this at the furthest point from the laser and work our way towards the laser. This is so if there is any thermal growth that occurs in between the beginning of taking measurements and the ending of taking measurements, it is minimized, because the closer that these movements occur towards the laser, the less effect it will have on any of the readings. When you do finish taking measurements, you should always go back and check those measurements that were furthest away from the laser and make sure that you're still getting the same readings that you had at the beginning of the process. We use a variety of bracketing to take readings. We have brackets that hook into the packing. There's brackets that allow you to bracket the receiver along the split line of the turbine and probe each of the bores. We also have magnetic bracketing. But for whatever the case, or whatever the measurement point that we are measuring, there's a bracketing available for it. When we take our measurements, we want to take a tops-on reading and a tops-off reading. This will allow us to see our measurements as they are when the turbine is assembled. And then we make all of our corrections when the top is off of the turbine, and we can account for the tops-on deviations when we make our movements. Any good laser system should base its measurements off of multiple points to calculate the center. What this will do is you probe many different points on the bore when you're taking your measurements, and it'll calculate the average center. It'll calculate all of these readings in order to give you the best possible calculation for the center of that bore. Once we have all the measurements for each of our points entered in the computer, we can now look at our results. Our results aren't going to mean anything until we can relate them to 2 points. We can fix 2 points at least in order to look at and see what our alignment looks like. These 2 points are normally going to be fixed either off of the bearings or off of the oil deflectors. These are pretty common in viewing the misalignment in turbines. Once we have those points fixed and locked into position so that there's 0 in the horizontal and vertical deviation, at each one of these points we are going to look at the misalignment of all the other bores that we measured, and we can make decisions based on that. We should also look at different views. We should look at a view for setting the alignment to the oil deflectors, or setting the alignment to the bearings, or any other set points that we may have in order to see what these deviations look like for the best possible correct alignment that we can do to the turbine. After we have decided on what our fixed points are going to be, and we are able to choose a view in order to review the misalignment of the measurement points, we can start to make corrections. Corrections are made in most laser systems by calculating the shimming that has to be achieved on both sides of the diaphragm in order to move it, or by the amount of machining that has to be performed on a key at the bottom of the diaphragm. If it is just simply moving the diaphragm up and down or left and right, we can monitor these moves by placing our receiver inside of the diaphragm as we move it so that we can do the calculations on a movement as it is occurring. After we have made all of our movements, we need to confirm our moves. We need to make sure that the position that we move has moved in relation to our set points as we wanted it to. In order to do this the easiest way possible, we are going to take a measurement again of our 2 set points that have not moved, and then we are going to measure every point that we have moved. When we compare this to our last set of results, our measurement points that we moved should have been moved exactly the amount that we wanted from the original set of results that we made our movements based on. No alignment is finished without a report. During Acquip alignment process, we generate several reports. We generate a graphical report right out of the computer. We generate an Excel spreadsheet of all the alignment as found and as left conditions, and we also generate a CAD drawing. Why is Acquip the best choice for your laser alignment needs? Well, at Acquip, all we do is alignment. We're experts in the field. We're able to take current technology that's available now and apply it to new problems. We continually think outside of the box to solve problems that are out of the ordinary. We have experienced alignment engineers who are dedicated to your specific alignment needs. We will go almost anywhere at any time without almost any notice. We guarantee your alignment will be done correctly the first time. Thank you for joining me for this presentation. For more information on Acquip products and services, you can contact our sales office at 407-401-9343. For any technical questions, you can contact operations at 305-538-7101. You can always find us on the internet at www.acquip.com, or you could send us an email at info@acquip.com. Remember, at Acquip, alignment is our business.